Next question reads, cosine squared theta minus 3 cosine theta minus 4 equals 0. Solve for all theta in the interval from 0 to 360 degrees. So again, we're still in degrees. This equation's nice because it's a trig equation where each term is in terms of cosine already. So at this point, I would treat this like a standard quadratic equation. And again, I would rewrite it as a typical algebra equation as opposed to a trig equation. So I would say let u equal cosine theta, and then I'm going to replace everything where cosine theta is with u. So we have u squared for the first term minus 3u for that middle term minus 4 equals 0. Right? So again, this is quadratic. When you're solving a quadratic with 3 terms, you want to set the equation equal to 0 first, and then from that point, I would always suggest factoring it. That's the quickest, easiest method. If factoring doesn't work, then you can resort to a quadratic formula. We're completing the square. So let's see what happens when I go to factor this. Looks like it's going to be u and u, and then we have to check it out. So it looks like it's going to be minus 4 and plus 1 here. Again, just double check mental math that if you multiply this binomial together, you get the original equation, and in this case we do. So now we're moving to zero product property. So that means u minus 4 equals 0, u plus 1 equals 0. And now we solve these for u. So first one, it's pretty basic. You add 4 and you get u equals 4. Second one, you subtract 1 and you get u equals negative 1 here. Now that we're at this stage, what we want to do is resubstitute cosine theta back in. So if you remember, let u equal cosine theta. So now I'm going to replace u with cosine thetas. So really I have cosine theta equals 4, and I have cosine theta equals negative 1. Right off the bat, I noticed something about that first expression, cosine theta equals 4. If you remember, all sine and cosine functions are defined. The value or the ratio on the outside here, whether it's sine or cosine, those ratios have to exist between negative 1 and 1 only. So this is obviously larger than positive 1, so it's an undefined value. So there's no solution for this equation here, and that's because 4 is larger than 1, right? So cosine theta, just as a reminder, must exist in the interval between negative 1 and 1. Since that's outside of that interval, that one goes away. And then next up, cosine theta equals negative 1. It's negative, but it's going to give us a quadrantial angle in this case, which is, again, so this is kind of a unique equation to solve. Remember, cosine measures your horizontal. And right now, negative 1 horizontally is all the way over here if we're on the unit circle, right? This is the point negative 1, 0. Cosine measures that horizontal value. And it looks like there's only one angle in this case that produces a negative 1 when you take the cosine of that angle, and it's 180 degrees. So here we would just turn around and say theta is equal to 180 degrees only. There isn't any other angle in a 0 to 360 degree rotation that satisfies this piece. So there's really only one solution here. Cos theta is equal to 180